Okay, getting ready for the STAAR test. We're on TEK A.9D, which is about graphing exponential functions. Here we see the equation y is equal to ab to the x. We remember that the a is our y-intercept or starting value, and we remember that b is the growth or decay rate. Alright, so let's take a look at this one. Which statement is true about this graph? Well, one, we could graph that. We can graph it easily on the calculator, and we will in a moment. But let's read through our answer choices, see if there's anything we can eliminate. The coordinates of the x-intercept, well, we know exponential functions, and that one is based on its equation, won't have an x-intercept. That's where the asymptote is, but we'll leave that aside for now. The coordinates of the y-intercept, well, we know what that should be. It should be 8, 0, 8. That's it. So the answer is G without us having to graph it or do anything else. The equation of the asymptote is, we know that asymptote equations in Algebra 1 should be y equals 0, especially for this equation above, not x. That would be a vertical asymptote. We don't have vertical asymptotes in Algebra 1. And the graph includes the point 2, 1. We could plug in those points in for our x and see if that gives it. Let's just go ahead and graph this equation. So we would open up a graph, 8 parentheses, 0.25, close parentheses, raised to the power of x, hit enter. There we see, as we would expect, it has a decay rate because the rate is 0.25. We see can't quite see it, but if I click and grab and bring it down, we can see the y-intercept is indeed 8. It does not have a vertical asymptote, and we could check all the things we've already said. All right, on to the next question. Which graph best represents? Well, once again, we could easily graph that just like we did, but we know some things about it. 2 is the y-intercept. So let's look. That could be 2. That's definitely not 2. That could be 2. That's definitely not 2. All right, so it's between F and G. We see that there is a growth rate of 5. We could check that by looking at when we have a 1 there. At 1, so if we were to plug in a 1 for our x, that'd be y is equal to 2 parentheses 5 to the 1 power. 5 to the 1 power is 5. 2 times 5 is 10. So if our x is 2, our y should be 10. 2, 10. Let's check and see. Not 2. When our x is 1, what did we plug in for our x? 1. When our x is 1, our y should be 10. So when we look at our 1, that's got a y value of 5. That's not it. 1, 5, 10. That is correct. F. On to the next one. It's asking us about asymptote. We know that the asymptote is the line that our function, as it's curving down, approaches but never crosses, never touches, in fact. And so t, while it's going in the right direction, is too low. Our exponential function is up higher. We know that this is not a asymptote. We won't have vertical asymptotes in Algebra 1, plus this arrow is going to the right. It will cross that line. It's certainly not Q, because it absolutely is crossed by Q. The answer for this would be line S, which is H. Asymptote would be the line that it approaches but never touches. All right. 2017, this was asked. We have the next question. We're given that same formula. Y is equal to A, B to the x. So we know 1/3 is the y-intercept, and the growth rate is, or decay in this case, it's less than 1, is 2/3. It has a vertical asymptote. We've said no. In Algebra 1, we don't have vertical asymptotes. The graph crosses, B, the graph crosses the y-axis. It's crossing the y-axis. That's our y-intercept at 2/9. No, it's supposed to be 1/3. It can't be B. The graph has an asymptote at 1/3. Well, we know they should be at 0 for this graph. We could graph it on our calculator and see the graph is decreasing from left to right. We know that's true because this is decay, because it is less than 1, so D is the answer. On to the next question. We're told that we have 29,000 and there's an annual increase of 6.2%. So if we were to write our formula, our starting value is 29,000 and our rate is 1.062 raised to the power of x. We remember for percentages we have to turn it into a decimal by moving it over 2 times. That would give us 0.062, and we can't just put that straight into the parentheses because that is less than 1. It would show as decay, whereas this is supposed to be increase. So we add 1. 1 keeps it the same, and the 0.062 grows it by 6.2%. All right, all that to say, we have our formula now. We can see that there's supposed to be a y-intercept of 29,000. The y-intercept on C and the y-intercept on D are both too small. 30,000, 29,000, it's just below the line. 29,000, just below 30,000. So A and B have the right y-intercept. And now we have to see which one has a growth rate of 6.2%. Well, let's think about it. Is 6.2% a large growth or a small growth? It's a small growth. We're looking at these two lines, how fast they're growing. I have a hunch which one it is, and hopefully you do too. But we can also test it. So we have this equation at 1. If we plug in a 1 for our x, what number would we get? Well, 1.602 raised to the power of 1 is 1.602, and when we multiply that times 29,000, would we be given a number slightly above or a number significantly above? We could type it in our calculator and see, but you know by now the answer is A. All right, moving on. The number of stores since 1992, and this is one of the graphs where we're careful to read the axis. So number of years since 1992. So right here it would be 0. And then the next year is 1 year after 1992, which would be 1993, and so on. Based on the graph, which one is not? Remember, you have to pay specific attention. When they throw the word not, they get a lot more students to miss it than otherwise would. All right. F. The company had opened 400 stores by the end of 1992. Well, since this is the number of years since 1992, we're looking at that time period. Did they have 400 stores at the end of 1992? Yes, that's true, but we're not going to circle it because we're looking for what is not true. So F is not the answer. The coffee company opened 100 stores in 1 year. Since this is using it in past tense, the company opened 100 stores in 1 year. It doesn't have to do that every year. It just has to have done it at least once. Did they open 100 stores? Well, if we were at 400 right here at this starting point, we're at 400. 1 year later, at 1, it looks like we are halfway between 400 and 600, which would be 500. That is 100 stores. 1 year from 400 to 500. So that is a true statement. It happened. And moving on from that point, we see it's increasing. So they would have opened even more than 100 stores in a year. H, every year, the number of stores that the coffee company has opened increased by 25%. So we're trying to see what was the growth rate. Well, we know already, we've seen 1 went from 400 to 500. How much growth is that? Well, 25% of 400, 1/4 of 400 is 100, and 100 plus 400 is 500. So that did grow by 25%. We can see that that is 25% growth. And we can keep checking at 2, what do we think it is, and see, but it is indeed 25% growth. Which leaves us with J. This one should be wrong. Since 1992, the the coffee company has opened 250 each year. Unlike the previous one, which said it just happened once, or at least once, this one is saying every single time. And we know that that's not true because we've already seen this first year that we did the showing from 400 to 500, it was 100 growth, not 250. So J is the answer. It is not correct. Moving on, we see a graph based on this information. Which one appears to be true? The car lost about 1/2 every 3 years, about 1/2. Well, let's take a look at it. Here we're at 0. We're in years. It's every 3. So we'll come over here and compare 0 to 3 years later. It lost about 1/2. We were at 12. And 3 years later, we're at 6. So that could be true. They're wanting students to go ahead and circle it. But you shouldn't. You need to check another one. So 3 years after that, we're at 6. So if it's losing half every 3 years from 6, it should be down here at 3. But we see that it is not. And in fact, we won't lose from that number 3 years later after that. We're certainly not going to be down another third. So we can tell that F is not true. G, it says it loses about 1/4 of its value every year. Well, let's take a look and see. We know we started at 12 every 1 year, every year. So at this point, it lost 1/4. We're at about 8.5. You might be pleased thinking that's close enough to the 9, but we would continue the same process that we did on F and see that it is not losing 1/4 of it every year. H, the car lost less of its value between years 9 and 10 than between years 1 and 2. So let's take a look between years 9 and 10. Here's 9 and 10. Here we are. How much did it lose between 9 and 10? Well, that is small. That's not even one whole amount. And then we're comparing that between years 1 and 2. Here's 1 and 2. Well, how much did it lose there? You see it lost more. So this is saying the car lost less between 9 and 10. That's over here, that small amount, than between years 1 and 2 over here, the bigger amount. H is correct, and we see J is the opposite of it, so it's certainly not true. The answer is H. All right, that is taking a look at exponential function graphs. Good luck.